Looking at the characteristics of the tangent function, just like we did with sine and cone at the very first page of our very first part of this booklet, the amplitude, there is no such thing as an amplitude on a tangent function. So just in case you were curious of that, period is the repeating pattern. The repeating pattern here now happens, you can see between asymptotes. So that's a distance now of just pi. The domain, so the domain is xe reals except where the asymptotes are. So we would start off saying x such that, and we tend to put our restrictions in first. You can do either way. You could put xe reals first if you really wanted, but this would be pi by 2 plus pi n. Okay, so every odd multiple of pi. So this would be x cannot equal pi by 2 plus pi n, where n is the element of integers. Otherwise, xe reals. The range, ye reals, says it goes up and down forever. So y is such that y is the element of all real numbers. The x-intercepts would be 0, pi, 2 pi. Now, of course, you might have a tendency to just list them, but if there's not a domain given, you need to list all of them. If there's a domain given, you can just list them each point. Okay, so this would be multiples of pi, so 0 pi, 2 pi, etc. So multiples, it's helpful sometimes to see the words too. Multiples of pi wouldn't be, this is just thinking it through, you would have to write your answer as x is equal to pi n, where n is the element of integers, so that's how the zeros or x-intercepts would be. The y-intercept is just one of them, so that's 0, so y equals 0 works. The asymptotes, well, we can use the domain that we just saw. The asymptotes are at pi by 2, 3 pi by 2. So the asymptotes was this notation here. It's pi by 2 plus pi n, so a distance of pi here. We use an equal to sign, though. You're stating the equation of that asymptote, so rather than the not equal to sign there. So you're taking out that restriction of the domain, and that would be what the asymptotes would be.